Okay. Um, so in this video, we'll take a look at the exercise, the class exercise that was given. So if you look at the first question, it's about the precise data, and this data set is in the car data packaging now. So you need to download this car package or install, okay, and then you perform the following exercise, okay. So, and remember this exercise is on Sakai as well, so you can just copy it. So what do we do? Okay, so first thing is to install. So if you want to install, you go to install, and then you enter car packages. You click on it, but you must make sure that you are connected to the internet. I have done so already. Now, so once you have installed your car data, you click on it so that you have access to it for this exercise. Okay, all right. Now, um, now, so the first thing is that at A, so 1A, so 1, question 1, I'm at A, right? A. Now A is that how can you show the structure of the data? And what data structure is this? Okay, so here to show the structure, I can use the str, right? And then I type prestige as okay, so prestige. As soon as I start typing, it comes here. So I can just check this. Okay, now, so this is a structure. It tells me that it's what? It's a data frame. Okay, it has 1, 0, 2 observations, and then 6 variables. The variables are all given over there. So you have education, you have about income, women, prestige, sensors, and then type. Okay. Now, so from this, you see, I can answer B without doing any other thing again. So, what data type is each variable in Prestige? Okay, so the A, so the structure, the variable types or the data types are so the first one is a vector, it's a numeric vector. Okay, so education is numeric vector, income is an integer. Okay, so in R, the numeric are real numbers. Sorry, the numeric are real numbers, right? And then integer are just the whole numbers, right? Woman is also, let me see, okay. If I should say one other way as well is to do question mark, right? If I want to do this. Okay, so yeah, so if you look at it, we have a factor, right? But the rest are all vectors. Okay, but if you look at it as a vector, if we go close into it, like we want to see prestige as in also view prestige, you will see that you have all vectors, and these vectors, some will be real numbers, others are what are whole numbers, so to speak. Okay, so if you look at the whole numbers, you have int, you have income, and what again? Income. Yeah, and the rest that are real numbers. You have uh, prestige, women, and so forth. So that's it. Now, as I was saying previously, I can also get the dimensions from here. So if I look at this, it says 105 observations with 6 variables. So that's it. That's the dimension of the data. Now, one other way is also to use dim, right? But dim, so if I that would also give me the dimension, which is 102 by 6. So there it is. Okay. So that's it. Um, then C, then C, we want to, okay, so to display the first 6 rows and last 6 rows, of course you can use subscripting, okay, but the easiest way to do is to use the head and tail. So head and tail. So I can do the head of prestige, but I can also do prestige 10. So this displays it quite nicely, but of course we can also say this is prestige 1 to 6, um, like prestige. Then we select the first 6 rows. So that's also another way. You get the same thing. Okay. All right. So for the we can also use tail, right? So the tail of prestige will give me the last 6 observations. Okay. There are other ways you can get the last 6. For example, finding the length or the end row, which is 102. Then you subtract 6 from it, and then you get a list of numbers beyond 6. Okay. The D. Okay, so D, we want to find what what is the highest and lowest income, which category of occupations are paid this income. Okay, so here I want to there are several ways you can do this, but I can use which Dr. Max. So which Dr. Max or here will give you the position, right? So it says the second position. Okay, so this is the position of the income, which means is um, the second. If I list income as a vector, the second value is the is the income. Is the highest income. Okay. So remember subscripting. I can use this to subscript the second um, the second row, and from the second row I can get what so which this is the second row. So this will put 2 over there, and because the question asks which category of occupation, okay, which category of occupation um yeah, so I do this, and if you look at it, it's all general managers. Their income is 25,000 something. So it's general managers. Okay. All right. I can also use a row name just to get the general managers, but I think it suffices to just subscript it this way. So that ends the exercise for question 1, and then now I move on to question 2. Question 2. Now, in question 2, what it says, what percentage of occupational incumbents earn more than 25,000? Okay. Now, this is logical. So, I want income. Okay. So, I want to get, you see, if I say income greater than 25,000, okay. So this is going to get me true or false. You see, all of them true, false, false. It's either it will only be true if it is greater than that. Okay. So the question is, I can sum this, right? Remember, um, the if I sum this, it is going to sum only the true because false is 0 and then true is 1. Okay, so only two people. Okay, only two people. I'm not saying this is the only way to do this. Okay, you can also use a which function to say which income is greater than 25,000 and you have 2 and then you find that. So it's up to you. There are several ways you can do this. But if I do the sum, that will give me the sum of the number of people who earn or number of occupations who earn more than 25,000. And I can divide this by what? How many? Of course, I can divide by the rows. And remember the rows is what? The number of rows is 102. So if I do this 102, okay. So because I want percentage, I can say 100 times 100 times the sum of so and so divided by the n row. And if I do this, it gives me what? 1.96%. Okay. All right. So that's it. Okay. And remember, if I want this to be in let's say 1 decimal place, I round this out and then it's what? 2. So this is approximately 2% of the um, of people earn or incumbents, occupational incumbents earn more than 20,000. Okay. Now question 3. So question 3. Question 3, we are to do this and what percentage of occupational earn above 20,000 and below um, and below 10,000. Okay, so I want to find, okay, so I can copy this, right? If I do this, let me put this in bracket, and is this, so those 20,000 and below 10,000. Okay, so I get my false, 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 and so forth. So I can pass this, I can find the sum of this, and it is 0. Okay, now actually this question should have been all. Okay, but it also suffices to do that. So this one I can say that no um, um, person earn, you cannot of course earn below 10,000 and at the same time below, yeah. So what I had in mind was to ask you about or, and if we were doing or, it would have been it would have been that we use this one. Okay, so this one, if you do it, you get 91 and so forth. But I mean, for now, what you should use is what end the zero. Okay, so nobody ends above 20 and also below 10,000. But if it was all, if the operating words of all, then you use the other one, which is 91 divided by 102. So yeah, okay. Now let me move on to 4. So question 4. So for question 4, I am interested in what constructing. If you go to, so we've done 3 and 4. So here I'm interested in construct a box plot to compare the distribution of income according to type of occupation. Comment on the distribution of each plot and the presence of outliers. Color the box plots with different colors of your choice. So what I need to, if you want to compare box plot, then you have to get this box plot on the same graph with the same what y-axis, or yeah, so that it is easier, either y or x-axis, so that it is easier for you to compare them and see which one has higher values than the other and so forth. So how do you do this? Simple. Okay, you can use the box plot. Okay, and first of all, I can call in the data, and the data is what? Prestige, right? Prestige. I'm not saying this is the only way. So whatever I do, you can always find another way of doing it. So what I want to do is to plot what? Income. Okay, so I come here. Remember, I'm copying from here because R is case sensitive. So if I now go and spell income, so I use a tilde sign. So I want to box plot income on what? Per the type of occupation. Type of occupation is type, right? Yeah. Um, yeah, so type is a type of occupation. If you look over here, type of occupation. So type, okay. And depending on the type of occupations I have, in other words, if you look over here, it says what? You have BC for um, blue color, and then professional training and technical, and WC is white color. Okay, so let's see how this is. Okay, so first of all, I get my box plot like this. Okay, nicely labeled, income type, and so forth. But of course, you can also label the y-axis. For example, if you can superimpose your income to it. Okay. Now, what about the colors, right? It talks about colors. Okay, so the colors, okay, and equal to, I can, because there are 3 box plots, I can say 1 to 3, and it will label them, right? 1 to 3. The first color is black, 2 stand for what? Red, and so forth. I can also do the same thing, okay, or I can do this by also calling the colors. Okay, so for example, if I want yellow, for the first one I do yellow. The second one, maybe I want blue, and the last one, maybe I want let's say um, green. I can do so. Okay, so this is another way. Okay, so there we go. There are several ways. You can even use rainbow. Okay, So the rainbow colors, the rainbow is also an R. So this one is to randomly select three colors from the colors of the rainbow. Uh, yeah, and so forth. Let me see. So if you want to do this, you can, yeah, look at rainbow. Um, yeah, and look at it. N is the number of colors you want, and so forth. So there are several ways in which you can do this. But let me come back to the plot and answer the other part of it, which is that we comment on the distribution of each box plot and also indicate whether there are outliers in the box plot. So here, if you look at this box plot, you see that the box has been divided into almost two equal parts, right? The whiskers are also, we can say, equidistant from the first quarter and the third quarter. So this is approximately normal. What about this one? This, we realize there are two large observations. So here we can say that this is skewed. Where is this skewed to? Remember, we have very large observations. So if you have just two large observations, so you will see that the tail of the distribution will straight towards the positive side, and we say it is what? Positively skewed. Over here, this one too, if you look at the box, is slightly not equal, so the down one is smaller than the top one, and the whisker at the top is longer than what the bottom one. So this is also slightly positively skewed, the WC. The income distribution here is slightly positive skewed. This is positively skewed with outliers. The other blue color and white color does not have any outliers, but the professional income by professional people have what have two large observations or outliers. So that ends question 4. And then I go to question 5. Okay, now for question 5, we want to construct a histogram for income of each type of occupation. Okay, so here you see for um, um, histogram, I can't get a histogram in one separate graph like I have done this way. But alternatively, I can also divide my plotting environment into 3 parts. So to do that, those that want to do more, you can look at the PAR. So PAR is also um, a package, or sorry, a function in the graphics, and it is used to set graphical parameters. Okay, so if I do PAR, right, and I use MF row, so if you scroll down here, you will see MF row. If you go to the, yeah, it's here. So MF column, MF row, a vector of the form C, number of rows, number of columns. Okay, so we use this to divide the plotting area. So I can do, so I want 3 in 1. I want all of them to be in the rows. So I'll say MF row, then I'll say 3, 1, which means, sorry, construct or divide my plotting area into 3, which have, oh, sorry, this one is 3 rows. So I have 1 and 3. The first one is the number of rows and number of columns. So here I want 3 columns and by 1 row so that they will all be in line, right? Okay, now I need to plot my histogram. Now to plot the histogram, I need to first select all the income of, let's say, what were the, let me scroll back to get the occupations. Wait, Yeah, prestige data. So the occupation, I have BC. So I can select all income with type equal to BC. How do I do that? Okay, so I can do so. I can say BC income. So income of B or those with BC. So I'll say prestige. So this is all about selection, prestige. Okay. Um, and of course, I want the column, the column called income. Okay, oh, sorry, income. That's why it's good to copy. Okay, income. By here, I want all prestige, right, with type equal to. Remember why I said I don't need you to do what? To BC. Okay, so the first part over here, we'll check which of these types is equal to. So you see, I get true, false, and false, and it is going to select all the true rows. Okay, so if you look at BC, those are the later end of the data. Then I say select only income. Okay, so let me see. If I do this, you see, so these are the incomes of people, or the income, and you can go and check income of all those things, of all the people, and these are the income. So when I do this, I get a BC income. So it means I need another one for what? For um, prof. Okay, now for prof, and then I'll need another one for what? For, so three of them, I can do this. There are other ways to do this quite easily, but from what we've learned so far, this is it. But I'm sure when I go through your scripts, I'll find other ways you can do this. So R, gives you the the flexibility to do your own thing, and I mean, you should explore most of these ways of okay, explore some of these ways. Okay, so when I do this, I'll get all the income, and then I can check this. Okay, so one way that we can do this is also to use a supply operation. So now here, maybe I can even give comment. Okay, select income each occupation, occupational type. So that's what we have done. And then now plot histogram. So now we want to plot our histogram. So the first one, I just go to hist. To plot a histogram, we use hist, and I do BC income. Okay, so now if I do this, now you see what has happened. Histogram of BC income. BC income is down there. Usually, when you do plot, it is not good to give a title like we have done, because if I copy this into Word, I'm going to name it like maybe figure 1.1 is what? A histogram of income of what? Blue collar jobs. Okay, blue collar observation. So is that you are going to name it twice. So you have histogram of BC income, and then you come down and say figure 1.1, histogram of so and so. So I entreat you that when you do plot, you must let the title be um, 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 empty, and remember because I did it the same thing. So remember what I did up there, the par MF rule. So we'll get our 3 rules like this. But of course, I need the other one, so I'll redo this. And maybe I want to color, so I can color. There are so many things you can do in, with R, and I entreat you to go to histogram and check, or you can use a par as well to do most of the things. So color, I may give it, there's a 6. I can choose any color for this. So the 6 color is, I'm not sure what this is. You can um, check this. Okay, so the next one, I can copy this and change to, um, the next plot is professional income. So I just copy and paste here. Color, maybe let me choose 10. Um, okay, so 10 is almost red. And then you see even BC income, you can change the S lab as well to a particular thing you want and so forth. So it's up to you to explore most of the things. Yeah, so this one is WC. Okay, WC. And color, maybe I choose 8. Okay, and there we go. Okay, so if you look at the first one, remember this is quite small, so this is all our box plot shows some normality. This one has what positively skewed because of this, and this one is also close to positive skewness. Okay, yeah. So that's it. That's our histogram, and of course it conforms to what we have done in the box plot. If you look at it carefully. Okay. So now question 5. We are done with question 5. So now question 6. So question 6. So for question 6, we are to select data on nursing aids and so forth. So these are the categories, right, uh, of yeah, the occupations. Okay. And I want to, so I can first of all get the row names of prestige. That will list all the names, and then I can copy and form a vector of it. Okay, so, oh, not end row, but I want the names. So row names, okay, row names of prestige there. Okay, so yeah, there are also several ways to do this. So first of all, I need nursing aids. Nursing aids. Or let me just go to my this thing and copy. That will be easier for me. Okay, so these are the occupations I want. I copy them, right? And then I name it as a vector. I'll pass this vector through. I could have selected them from here, but it will take time, so I will just copy this. But that's another way to do it. Okay, so I can say this is our names. Let me say, give it a vector name, our names. So C, and then I put this in there. Okay, so I put each of them. Remember, these are um, characters. Also, they are strings, so I have to put them in what in inverted commas. Okay, so taxi drivers. Oh, sorry. Okay, longshoremen. And it's not part of it, so I take it off. replace it with um, bookbinders. The full stop is not part of it, so I take it off, and then now I run this. Okay, so there it is. I'll need. So I can just take Prestige. Okay, and then um, um, the rows. I put this one here because I want to select all the data. I mean, I need all the columns, so I'll just leave it like that, and there. So if I um, if I want to, yeah, so the nursing is that's the education, that's the income, that's the women. Of course, I don't have enough space to take this because of my plot. But if I make this very small and then now I run this again, I'll get all of them on the row. So there it is. So this is how you select. As I said, there may be several ways of doing this, and it's up to you. But of course, I need just one. Okay. That reminds me. Okay, so in your report, sorry, I did not talk about this, but how do you copy the graph to your Word document? Well, you can save it. Okay, you can save it in anything PNG and so forth. I require PNG because it gives you very good um, picture. Okay, so you can save to your folder and then you go and copy. Or I also gives you the to copy to clipboard. So you copy to your clipboard, and then if let's say you come to um, Word and you want to present this, all you have to do is just paste, right? Okay, so if I'm assuming this is my my work to present, and then I paste this, okay, and it comes quite easily here in Word. So you can copy it just like that and paste and so forth. Okay. All right. Next, let me go to question 7. So we are done with 7. We go to question 7. Okay. So for question 7, we are to construct a pie and bar chart for the type of occupation. Comment on the figures. Okay. So here we want pie and bar chart and bar chart. So what do we do? First of all, um, we type, so I can say type of occupation. Let me say this is my vector. Okay, so first of all, to do these things, I table them. What do we mean by table? You create a frequency table for them. Because remember that this will be a raw data. So if I go to Prestige, okay, and I want to select what type, and I do this. Okay, so this is a vector, is a what a factor. Okay, I can't just take, let's say, pi, right? So just pi, because to create a pie chart, you use pi, right? So I say pi and then I do this. It's error. Okay, it can't. So what I need to do is is to table them so that I get a frequency. And that's what you do when you are constructing a pie chart, right? You get your frequency and then you can, take your convert it into percentages, what have you, and get your degrees and so forth. So this is a table, right? So if you go to pi, let's say you go to check the health files for pi, it says x. X is a vector of all non-negative numerical quantities. The values of x are displayed in the areas of the pie structure. And then the labels, the edges, and so forth. radius, what have you. So there are so many things you can do, color and what have you. Okay. So now that I have type of occupation, I can do that. I can create my pie quite easily like that. Remember that I have divided my plotting area into three. That's why it is causing that. So for example, if I want to get my pie and my bar chart on the same plot, I can go and copy this and maybe divide it into two, only two, because I don't want three. I just want two. So I change this to two. I run it. Okay. And then now let me clear this. Okay, so if I do this again, I'll get two. Okay, so this should be there. The other part is also, and for bar chart, the command is what, or the function to create is bar. Sorry, bar plot. Yeah, bar plot. Okay, and I can give it this. So all of them I'm using default. Okay, so prof. So here you see I can give it X label, X lab, and my X label is what type of occupation. Type of occupation. Okay, so it's like I'm starting over again. And then here, um, if I want it to be a type of occupation. For the type, I made a mistake. Okay, so I can copy. For the bar, for the pie, we may have to make it yeah, so type of occupation. Okay, so that's for this. Okay, if I run them again, then it means the the x-axis will be um, good for it. So that brings us to the end of question 7, and I can go to question 8. Question 8. In question 8, if you go back to this, question 8, we have to comment on the figures. Okay, so let me go back. So here we can say that BC has the category BC has um, the they are many. Okay, they are in the majority, I think, followed by the professional groups and then WC. And you can see it from here, the highest frequency this and so forth. So that will be your comment on the distribution. Of course, each of these we can put even the percentages right alongside it and so forth. And if you watch the other video, you will be in a position to, if you install the Protrace package, you'll be able to design this bar chart quite nicely. You can take some slices out, so that and so forth. So you must look at it and be able to um, um, plot some elegant graphics for some of this work. But I will leave that for you to practice. Okay, so now let me go to here. In 8, we have to compute descriptive statistics, okay, of income, of incumbents, to enable you describe this to a journalist from daily graphic. In a nutshell, we want you to be able to get some descriptive statistics that will help you to describe this data. Okay, remember your package, the package we talked about, that psych, for example. Oh, sorry, This thing is frozen. So remember psych. Okay, but the first point of summary, let me say, is to use summary status. Summary. So if we use summary like this, and we go to prestige and we say income, is going to give us some. So the minimum value, the first quarter, the median, the mean, the third quarter, and the maximum. So this is the first thing, but of course, this one doesn't give us things about the variation within the data and so forth. But of course, from here, we can find the range, the maximum minus the minimum, and add it and so forth. But if we load the psych package, which I talked about in class, then there's even a more better function called describe, which will give us more descriptives concerning this income. Okay, so look at it. Number of variables 1, the sample size 102, mean 6797, okay, 0.9. Standard deviation is what? 4 that. The median is this 590, which corresponds to what you have up there. This is trimmed. Okay, so what do we mean by trimmed? Okay, so when you find a mean, okay, because the mean is affected by extreme values, that is very large or very small value. Sometimes you can take, let's say we call trimming. So if we trim it as 5%, it means you take 2.5% of the top other top values out, and then the 2.5 of the very small values out, so that you are left with what is in the middle of it. Okay, so that's what we mean by trimmed mean. Then the mean absolute deviation is also given minimum, maximum. The range is calculated for you. Skewness, this is 2.13. So we say that the data is what positively skewed. The kurtosis is 6.29. So it's more or less not a normal distribution, right? And then the standard error of the mean is 420. So this gives you even more of data or descriptive statistics on this. So you say that it's positively skewed, okay, and what have you. So that's about 8. And then if you can provide some simple descriptives like I have considered, telling us whether the data is positively skewed, negatively skewed, and so forth. Okay. Now question 9. Question 9. We say obtain scatter plot of income and prestige. Okay, so we want to construct a scatter plot of income on prestige, and then we label the axis correctly, and then we use plotting character 15. We comment on our relationship. Okay, so there we of course this is bivariate plot, so we need plot. Okay, now the x is what? Prestige. The x-axis we want prestige, okay, and then y we want prestige income, prestige through income, okay. And remember that it says plotting character should be what? 15. So plotting character is PCH, which is okay. Let me first start with a simple one, and then I'll add on. Okay, so if this is it. Okay. I need to clear off this. So one way, so that it's not in two parts, one way is to use graphic clear all plots. If I clear all plots, it will reset this place. Alternatively, I can also use the same function I use mf row, okay, C, and then here I want one row, one column. So I can do that, and that will take off this one. So this is it. Remember, what do you have? You have a prestige, dollars, and income. Prestige, if you are going to give this to your manager who doesn't know anything about R, or they say the journalist who is very graphic, and you say prestige, dollar sign. The person will be wondering whether prestige is a dollar sign or what have you, right? But this is your R. It has nothing to do with the person you want to let the person understand what is happening between prestige and income. So it is imperative on you, like to be able to label this correctly, and that's why in the this thing I say label them correctly. So the S axis is actually prestige, okay, and then Y axis. So that Y axis will be Y lab, and Y lab is now what income. So this will um Yeah, so you have this quite nicely done. Remember, I said you shouldn't put any title here. So I don't want any title there. But let me take this opportunity to also add some few things. Look at this, please. So here, you see there's nothing there. I'll intentionally leave this because our things that you provide a title, but you are not. Over here too, there's a space there, which you don't need when you are um, um, when you are copying. So if I copy this to Word, all this place will occupy an empty space. I can't do anything to it in Word. So because R gives you that flexibility, okay, I can close all these places. So here and there, where I don't need anything over there, so that my graph will extend to this place. This is very crucial, especially for those who will be working, when we're doing presentations and so forth. So this is also in PAR as well. If you go to the PAR um, health files and then you want to use it, you can use um, it is called ma, right? So ma is also a vector which is 4. The first one is the space over here. The second one is the space over here, third and fourth. So, but if I give 4, 4, 4, it is enough. 4 inches is enough for me to be able to get my label here and there. But here, I don't need anything there. So I can put 1 and 1 here, 1 here. So if I run this, it's going to, I added this to the par. So yeah, which is legitimate because they are all in there. Now I'm going to plot again, and please note the changes. Have you seen? So you see, I have very little space over here. My graph occupies almost the entire space. It is really irritating when you take a project work and so forth, and then somebody plots something, and the main plot is sitting somewhere small area, and then all these places are just like space that you cannot do anything to it in Word, especially those plots you get from Excel and other programming language. So this is very important. So it makes sure that when you get your plot is very boldly enough and occupies all the space you need for this. Okay, so by default, the plotting character is this one, the first one, the circles, right? I wanted 15, so I'll just say PCR is equal to 15. Okay, PCH, okay. Now look at what will happen. Okay, so this is the plotting character 50. And if I want to get this plot, I also can copy. If you want to save it, you save. I can copy and paste in Word and then comment on the relationship. And of course, the relationship between this is what? There exists what? Some positive relationship between what? Um, income and prestige. As prestige increases, income gradually what? Increases. So, okay. So that's a comment on the relationship. Okay. And then lastly, question 10. Question 10. Okay. Question 10. Compute the correlation coefficient of income and prestige. Okay, to do that, I can just say call, and then I take this prestige and income, and yeah, it gives me the value, which is what? 0.71. So there is some strong positive correlation between what? Prestige and income. Okay. But now I need confidence interval. So this will not help me, but rather, okay, so if you go to core, if you go to the held fast for core, so it tells you about the correlation and so forth, but this will not give you confidence interval. What will give you confidence interval is core.test. Okay, and if you, okay, so this does not give an indication, but I can say core.test there. So for this one, it tests for association. Okay, so those doing 2, 2, 3, this is what we did. We test concerning the correlation coefficient. So in R, you use what core.test to be able to do that. And it's a stars package. So stars package is automatically loaded into our studio. So we don't have any problem with that. So core.test, but the alternative, remember, this is two-sided, which means you want to test whether they are not equal. This is less if you want to test whether the population correlation coefficient is less than 0, and this is when the correlation coefficient is what greater than 0. Okay. So if I want to conduct this test, I can copy this and delete those that I don't want in there. Then X and Y, of course, I know my X and Y, so I can just put them inside here. Alternative, I think for now, let's do with two-sided, right? So two-sided, I can take it off from the vector because it's just one. Now the method, which method do you want to do? So remember, you know from your 111 Pearson's, Kendall, and so forth, Spearman, you can use any of them, okay? But for now, let's say we want Pearson's, right? Okay. Now, this is also good to know exact. I will just leave it at null. Okay. But confidence level. In the test, I did not even give you any confidence level. So let's just assume that it is a 95, which is always the case. What is usually used. So we take up the double does means that we can provide other arguments, but we are not interested in that. So we just end here. Okay, so if I ask you to test at 10% confidence level, then you should change this to 0.90, but it wasn't stated. So let's use X. Okay, so I made a mistake here. Okay, there. Okay, so now I'm in a position now to do this. Okay. All right. So this is it. Okay. So the results is here, and the result says that Pearson's product moment correlation coefficient, right? Data is prestige, and then prestige income. My T value, remember in R we were, in 223 we were able to compute this. So T is what? 10.224. DF is what? 100. Okay, remember I said it has your test statistics. Let me see. So your test statistics was so those doing 223. The test statistics for this is T. Let me look for the formula. I don't really type in Word. So insert. Okay, but you take any reference test, and if you want to test about the correlation, remember the t you compute, which is r times the square root of n minus 2 divided by the square root of what 1 minus r squared. That statistics is distributed as what? As a t with n minus 2 degrees of freedom. Okay, so that's it. So n minus 2, we have 102, so that will give us 100. That's why the degrees of freedom is 100. The p-value is very small, so what do? We will reject. How do you decide with the p-value? If the p-value is less than your alpha here is 5%, the level of significance. Okay, look, this is the confidence level is 0.95, so alpha is 5%. So because the p-value is less than your alpha, which is 0.05, we reject the null hypothesis. And what is the null hypothesis? The null hypothesis is that there is no correlation between the two variables, prestige and income. So, in other words, there exists significant positive correlation between prestige and income. So, as prestige increases, we expect income to increase. Now, alternatively, we can also read from tables Tn minus 2, so T of 100 and what? And at 0.025. Remember, this is a two-tailed test. Okay, so you divide your alpha into 2. Now, you can also do so. So we use the quantiles of the T distribution, right? P is now, so the P, I can use 0.975, which is the top part of it. And my degrees of freedom, which is DF, I use 100. Okay. Now, so this is 1.98. This is what you will read from books. Now, alternatively, I can also use the 0.025. Okay, but that will give me negative. Remember, and that is the negative of the other part. Remember that we said that for the two-sided, the T, you see, once you read one, you negate it and you get the other. So that's how you do this in R. So if I'm using this T, what is my rejection region here? Of course, my rejection region will be that I will reject H naught, right? If I have large values of T, in other words, if T is greater than T n minus 2, okay, what is my rejection region here? I will say reject H naught, reject H, what is it? H subscript. This you've done in 223. So I don't reject H naught if T is greater than T, right? And this T, you want T with what? N minus 2, right? Okay. Or, okay, so what do you do? Or if T is less than negative T. So this is what we were doing in 223. Okay. So for two-sided, you will reject if T is greater than this, or if T is what? Less than negative that. This value will be the same, and that's why you have negative 1.98 and positive 1.98. So we go and get our T value. Our T value here is 10. Sorry. Oh, the T we computed is 10, right? If T is equal to 10, what do we do? Of course, it is over here. It's greater than the 1.98. This one is a, oh, sorry, it should, I don't want this. So this, from the tables, we got what? You get 1.98. And here it will be what? Negative 1.98, right? Negative 1.98. So because our value is 10 and it falls in the critical region, we reject H naught and conclude that there is a significant correlation between them. So that's how you do this. Now, that's one. So one, you can use a p-value to conclude your test that the p-value is less than 0.05. So we say that there is this significant correlation. Alternatively, we've used what the T from tables and one we computed from our sample to do that. Another way is that this is the confidence interval for the correlation coefficient. Okay, so the 95% confidence interval for the correlation coefficient is between 0.60 and 0.8, if I should approximately. Now, this interval excludes 0. The 0 is when there is no correlation. So we can reject the null hypothesis that there exists no correlation between them. Okay, so in other words, there exists some positive correlation between prestige and income. And that ends this discussion on this assignment. Okay, so I'll post it and then everybody will read and watch and complete it.